Hi, everyone. Thank you for joining us. I know it's like the last session of the day, or one of the last sessions of the day. You're probably fairly tired from the other talks and going around the booths. So thank you for coming and coming to see what we've got to say. And I hope you can get one or two at least tidbits of useful information from this talk. So first of all, I'd like to thank our friends here at Barclays who've agreed to come and chip in. So that basically their use case inspired this talk and the demo we're going to be doing later. So we're grateful, really grateful for them to coming along, and they're going to be talking a little bit about the use case shortly. Obviously, thank you to my colleague Matt Moorcroft, who's done most of the legwork on this, as you'll see later on. So yeah, if you've got any tricky questions, there for him. So I actually have two versions of this talk, because the first one got rejected. Because the reason it got rejected was because I put it in, and they said, well, hang on, your talk's on Tuesday. All this stuff's being announced on Wednesday or Thursday. So if we did this talk on Thursday, it would probably be quite different. So where you see certain names, by tomorrow, you'll think, OK, that's what they were talking about. There's a few things. But anyway, lots of these things are the worst kept secrets anyway. So I'm sure it'll make some sense. But basically, this talk is hopefully going to give you a flavor of lots of different components which are going to be announced in the keynotes Wednesday, Thursday. This is going to talk about a real-life use case which uses a lot of those components. So I hope in that sense it gives you a flavor for how they can be used, why Databricks is building those in the first place, and how you can join those components together in your own use cases. OK, so surveys, please fill them in at the end. We'd love to hear how you rate the talk, whether it was useful, whether it wasn't useful. Please be honest. So we can do better talks next year. So here's the agenda for today. I won't go through it in too much detail because obviously we want to focus on the content. We do have a live demo at the end. Fingers crossed. If the demo gods bless us, it'll work. Yeah, but you can see from there some of the topics we're going to cover today. And hopefully there's some things in there which will resonate with your use cases. OK, so over to our Barclays colleagues to introduce first introduce the relationship.
Sure. My name is Harsha Ele. I run data platforms and data management at Barclays. What that means is basically standardization of data is a big thing, right? We look to standardize across multiple domains, but more importantly, within a given domain, for example, the trade domain, we offer about 350 different products, right? We are one of the big market makers when it comes to banking markets world. So across this, we standardize largely based on ISO and FPML standards. The data platform side of things is where the most of this talk is about, is authoritative data sources, which hold all sorts of authoritative data, i.e., when a regulator comes in, we are able to stand behind this data, knowing that the quality of the data is good, and we are able to present that data, right? So we are talking about trade stores where all the trades and the executions are kept, orders, quotes that we send out to the markets, right? And all the payments, journals, wires, all those data are kept in these different authoritative data sources. That's what I manage and maintain, and my team does. In terms of what we are trying to achieve or what the objectives are in the business context, I thought I'll take a couple of minutes to set that, right? So every other big organization, we have multiple platforms, multiple sources of the truth. I know that I just talked about ADSs, but still copies of the data are kept, right? So we are trying to get to a stage where we have a unified data platform, a single source of truth, so to say, right? So when we have to do AI, ML use cases, that we go to the same source of data, same copy of data, like when we have to do analytics and such. We wanted to have the flexibility of the lake, as well as the power and performance of the warehouse, right? So that's one of the key aspects so that we can run not just analytical use cases, but also operational use cases, right? We do have structured data, but we also have a lot of semi-structured data. So a platform that seamlessly supports and efficiently supports both these, right? And as I was telling, we have a plethora of different platforms, Hadoop, a lot of Spark workloads. So we wanted something that can provide a seamless glide path, so to say, like for future migrations. Finally, real-time ingestion and real-time analytics, which is the topic of today, wherein my colleague will present what the problem is, what the use case is, and Matt and Matthew are going to talk about the solution, proposed solution. And finally, we were looking for a partner and vendor who is committed to open source. Interoperability will be key, right? Even though I said unified data platform, we are under no illusion that it will be a single vendor or single technology platform. So interoperability is key. Commitment to open source is key. And a great partner is what we were looking at, who will work with us hand in hand in order to achieve these objectives. With that, let me hand over to Shiram to talk about the challenges with real-time and the opportunities as well.
Okay. So I am Shivram Iyer. I work closely with Harsha on the data platform for Barclays. And as we talk about traditional warehouse, right? I mean, every warehouse has three types of ingestions, right? One is end of day, one is real time, and one is near real time, right? So when we start the development on a warehouse, the real time, the expectation is that the data basically is available in the warehouse, say within milliseconds, microseconds, whatever. But as the workloads increase, you realize that the traditional warehouse has limitations on the number of sessions that you can run at a particular point of time, and your real time never stays real time, and it becomes a minute, or in certain cases when the workloads increase, it's 5 minutes or whatever, right? And in 90% of the cases for catering to the real-time warehouse, you basically build a solution that is outside of the warehouse so that business has faster access to the data. And what you're seeing over here is primarily an architecture that is currently used to load this real-time data into a traditional warehouse, right? Where you batch the data, though the data comes real-time to the data warehouse. You don't load the data real-time due to the limitations that the traditional warehouses have. You batch data using Camel and other frameworks, and you basically use the batch-oriented nature of the warehouse to get the data to the warehouse, and business gets this data in dashboards 5 or 6 minutes later. So the opportunity cost that the business has, to view the data and make informed decisions is lost over there, right? So that's where, we basically, got engaged with data warehouse, and, we started looking at, avenues or opportunities on how we can use the lakehouse architecture that Databricks provides, and also cater to the real-time use case, right? So everything remains within the lakehouse architecture rather than moving out of the lakehouse architecture, right? So the current model that we have, within the firm is for real-time use cases. We have KDB, we have 3Forge, we have myriad tool sets that are used for real-time data ingestion. And to Harsha's point, that also comes with multiple copies of the data. The same data is maintained in 3 different places, and that also increases the storage cost, your compute cost, and everything, right? So that's where we basically partnered with Databricks, and they are helping us with coming up with that unified solution, which will not only enable the near real-time and end of day sort of use cases, but also enable the real-time use cases that the business can use for informed decision making in a more efficient manner. So over to you, Matt. Yeah, thanks.
I just wanted to say, volatility is can go super high and very, very different from the average volumes that we see, right? Liberation Day, for example, saw 3x, 5x volumes in each of the asset classes. When you combine that in a horizontal authoritative data source, you are talking about 7 billion quotes suddenly, right? When the average is about 2 billion, right?
Okay, so when we first tackled this problem, this was sort of back, I think, about Christmas time. My first thought was what kind of tools would we typically use on Databricks to solve this problem? And this probably is a fairly common kind of architecture that people would sort of see. There's nothing really too new here. So the first tool in the box you'd go for is traditionally structured streaming, Spark structured streaming. And that's typically what you'd go to do real-time dashboarding. But there's a few pain points here, and it's not as smooth as it can be. And although maybe Spark structured streaming can do the low latency, there's some issues with this approach. And the first one is, in terms of ingesting, so most of these data sources come in, very few of them come in on PubSub. Some do come in on PubSub, but lots of them come in via APIs and WebSockets. So traditionally, it's been difficult to support those custom ingestion without using Scala. So it's been difficult to implement that in Python at scale. So often Scala's been used. So that's a bit of a stumbling block because we want to have Python end-to-end so that the users who use this platform don't need to learn Scala to do the ingestion. There's another problem with this approach, and this is that actually, although structured streaming can be super low latency, if you're doing Kafka to Kafka with structured streaming, then you can get to around under 1 second latency. The issue is, with this approach, is that if you want to create a dashboard off that data, you have to persist it somewhere. So you have to persist it to a Delta table. Now, we probably all know Delta tables, because you're going an API round trip to blob storage, that realistically, you're already adding on 5, 6, 7, maybe even 10 seconds of latency. And as that volume increases, if you don't optimize it correctly, that can quickly increase. So already you've got some delays to your dashboards. And then traditionally, obviously, if you're Databricks users, you'll be familiar that the Databricks built-in dashboards can only refresh every minute. So that's fine for many use cases, but lots of times the business will come to you, particularly when they start, like mentioned earlier, when they start getting their hands on the data and they realize the benefit of it being real time, they suddenly go, actually, that dashboard you created that updates every minute, that's not good enough, we want it quicker. So what happens then is the end user dashboards, the end-to-end latency ends up being maybe 60, 70, 80, 90 seconds. And suddenly what you said to the business you were going to position as a real-time dashboard suddenly is quite laggy, and the customers start complaining. And so then what happens is you end up having to use an alternative approach where perhaps you use structured streaming, but you then push the data to maybe a NoSQL store, and then you have another dashboarding tool. Perhaps you use like the Power BI API to do a real-time refresh. But the problem with all those approaches is you're then pushing the data outside the system. You need new technologies to support. You need new governance to support. And it adds complexity and it adds to the learning curve. So can we do better with some of the new components which are being added, particularly to Delta Live tables and OLTP and Databricks Apps? So these are the 5 components we're going to talk about in this talk, which allow us to actually move that dial from, instead of being like a 90-second lag, to actually being like a 1 or 2 second lag. So the first thing we're going to look at is Lakeflow DLT. So there's a bunch of new features which come into DLT, and some of these apply to structured streaming as well, which help us to get the latency down. So the first one is real-time mode. That enables us to reduce the latency from structured streaming was typically like maybe 1 second down to less than 1 second, particularly if you're doing things like Kafka to Kafka or Kafka to an API. We've got custom data sources. These are in open source Spark as well. These allow you to, so where that initial problem that I mentioned, where actually you needed Scala skills to potentially to ingest from WebSockets, Python custom streaming data sources are a really nice way to create portable Python connectors which can talk to multiple data sources, whether they be WebSockets, APIs, PubSub, or some other technology. So previously, DLT couldn't write to JDBC directly. So you'll see we've now got the for each batch sync, which allows us to write to JDBC, and you'll see how that's used in the demo later on. And then finally, we've got the new transform with state in Pandas API, which allows us to use Python to do some really complex stateful manipulations. Okay, so what are the benefits of this approach? So why do this? Why not use an existing tool? Well, yes, there's some great tools out there, Prometheus, Grafana, the traditional ones for doing real-time dashboarding, those kind of technologies. And they're great for this use case. But obviously, they do add layers, and they do add a bit of complexity. They need infrastructure management. The users need to understand them. Potentially, if you're modifying dashboards, that might be quite complex. What does this approach give us over those? Well, it's very simple, because all those components can be deployed very easily. Lots of them are serverless or have the option to be serverless. They can take advantage of the auto-scaling that you get within DLT and things like schema evolution. And we don't need additional skill sets. So potentially, this is where Databricks Apps comes in, is potentially your data analysts can create their own apps without necessarily requiring external developer resource. And the final point on there is quite important, is all these components can be deployed very simply with Databricks Asset Bundles. There'll be lots of talks on that if you're interested in it. It's a way of packaging up Databricks components using like a simple YAML structure, which allows you to define the Databricks components and deploy them as you would if you were using, say, Terraform. So all of these can be deployed using a simple CI/CD pipeline. And of course, you get the governance over the top. So the governance then is, you don't need if you had an extra technology in, you've got to manage the governance of that technology. With this one, because they all tie in or can coexist with Unity Catalog, they'll use the same service principles, and the same users and groups can be used as you've got defined in Unity Catalog. Okay, over to Matt.
Perfect. Thank you, Matt. So I'm going to dive a little bit deeper into the different components that Matt was talking about, and starting with real-time mode. And real-time mode is a new execution mode that is available in Spark, and it differs from the standard microbatch mode that is standard with Spark as well. The reason we created real-time mode was because there was a gap in the Spark ecosystem where we wanted to achieve sub-second latency, but microbatch, like the standard mode, wasn't capable of handling it. And don't get me wrong, analytical, like the standard microbatch mode is great for analytical queries. It has amazing throughput. But there's some situations where sub-second latency can be critical to different customers and use cases. Specifically, real-time mode comes into play when you have a lot of machine-to-machine communication, like Matt was mentioning, where you may potentially want to have a layer of transformations within your analytical platform, but sending it out for a system to take some actions on. In trading, that could be signals, it could be alerts that may notify different systems of anomalies in the market. For the dashboard specifically, the standard execution mode is more than enough because it can achieve 1 to 2 second latency. So for the visual part of it, no need to go to real-time mode. It's only primarily when you're focusing on machine-to-machine communication. In terms of how that looks like under the hood and how does this execution mode work? Well, it differs significantly in the way that Spark originally was designed to work, and the microbatch mode is very similar to the standard batch mode as well, where you are doing batch processing. And it's basically sequential. We parallelize the task between multiple workers, but the execution will go in steady steps. So the first stage, you may be reading from the source. Second stage, you do some processing, and then you write to a sink. And you checkpoint the progress that has happened in that execution. In order to achieve sub-second latency, we had to redesign how we approach this process. And the way that this is done for real-time mode is that we'll do reading and processing in parallel. So you'll have tasks that are continuously reading from the source and tasks that are continuously writing and processing that data to the sink. And you may think, why don't we go with the real-time mode all the time if it's going to be more efficient? Well, the reason we don't choose to go with real-time mode for most use cases is because it has some caveats to it. Primarily, that the checkpoint, as it's not being written every time you process, you now get at least once guarantees, which means that you may get duplicates if the pipeline fails or you stop it and you restart it. So by real-time mode, it's a time-bound checkpoint where you specify the time you want it to run, and after a specific time, you'll checkpoint the progress that has happened, whereas with standard mode, every time it processes, it will checkpoint, so you can get exactly once guarantees. But in some situations, having duplicates can be acceptable as part of your pipeline, and achieving that sub-second latency is more critical to it. Okay, moving on to the components that we have in our pipeline within DLT. Starting with the custom streaming data sources. And this is something that Matt has already introduced. And basically, the custom source is a way for you to build connectors within the Spark ecosystem. The same way that you do a read delta, you can actually read custom source. And there's specific classes that you can extend and implement to build up your own connectors. And the use cases that we tend to see this best suited for is things like JDBC, where you may not have CDC natively available, so you implement your own. REST APIs, where they don't have a native connector. You may have WebSockets that you could design your own way of managing the streaming for it, as well as many other systems. The way that we designed it for our pipeline is that we have 2 different sources. They're coming from the same API, which is a trading API, but we focus on two different sources and different schemas for it. One of them is a trade data source, and the other one is a quote data source. And each of these will have its own class and its own definition on how it should look like, what data you expect from the source. And overlapping both of those, we have a streaming reader. And that streaming reader is common between both data sources because it's just a way of interacting with the native API. This design, I would mostly recommend for situations where you really don't have native connectors. I would treat it more as an extra for your pipelines instead of the go-to. The reason is because it adds its level of complexity where you have to develop your custom sources, but still it's a very powerful feature that extends a lot of what's possible in Scala into Python. Now that we've ingested our source into the platform, we don't necessarily need to use transform with state and pandas for everything that we do. We may have situations where we'll read from the source, write it to a table, or write it to our target dashboard. But there are situations where doing some state analytics and processing is required. Some of you may be familiar with applying pandas with state. Not sure if anybody in the room has ever used apply pandas. Yep, I can see a few. Well, transform with states and pandas is the version 2 of that. It simplifies the way that we build stateful processors, but also actually extends its capabilities compared to what you were able to do with applying pandas. Applying pandas is function-based. Transform with state and pandas is a class where you define how you want your state to be managed based on what data you're reading and what you want it to do. It has way more composite types, whereas applying pandas only has single value. But I will not go into too much depth in terms of what you can do. It has a way more features than applying pandas. So if you ever want to do custom state processing, go with transform with state. The way that we implemented it for our pipeline is we use it for something more specific, where we may receive tick data from our trading source, and we want to do some analytics, and specifically in this situation, we want to do a time-weighted average. So we basically will be ingesting the data, and as we ingest the data, we tell the state processor that to lag for 5 seconds in order to stabilize and get an average of what we expect the price to be, and then send it out to a sink. And the way to do this with the custom state is actually makes it so much easier, and it makes it easier also to govern and build pipelines this way. If we go to for each batch sync, once we've processed that data, we've done some analytics, and we've done some transformations, we want to write it out to our custom sync. For each batch is something that has been present for many, many years in Spark, in structured streaming specifically, but it was not there for DLT. And that made it have significant limitations for many use cases where you don't necessarily want to write to Delta, you may want to write to other systems as well. And it was a really pain, and customers would not adopt it because of these limitations. Thankfully, we now have it part of DLT, which simplifies a lot of the processing that we do in terms of writing to custom syncs, and it actually increases the adoption of DLT, which is what we want to do to make it easier for people to build pipelines as well. You may be asking yourself as well, can't I use the custom source to write to these things as well? And actually, that's something that I didn't say, but with the custom sources, you can actually build syncs as well to communicate with those APIs. So you could potentially be able to write as well as read over there as well. But in some situations, you don't want to do that. You want to keep it simple. Well, for each batch is a way of building your outputs towards a specific sync. In our case, we're going to be writing to OLTP, which is going to be served as a caching layer for our Databricks apps. But you could do it for different systems as well. Another caveat to for each batch sync, which you can see that Delta is there. I would recommend you write to Delta directly instead of using for each batch sync if you can, because if you write to Delta, you get exactly once guarantees, whereas for each batch sync suffers from the same thing that real-time mode has, which is at least once guarantees, where we are not sure about the checkpoints, so you need to keep that into consideration if you get duplicates as well. How did we use it? So in DLT, there's two components that you need to use in order to use for each batch. And basically, that's a for each batch sync component, which is very similar to what you would have in structured streaming with for each batch, where you put the logic of what you want it to do. Specifically here, we're writing it to an OLTP, so GDBC connection, and a pretty simple process in terms of writing it to that database. Append flow is a common component between a lot of different features of DLT. So you could use append flow to ingest, but you can also use it to write to different sinks. And specifically here, we're using append flow to move the data from specific tables in DLT towards our for each bat sink. We can also do that to write to different things as well. Moving on to OLTP at Databricks. Well, OLTP is one thing that we've created in Databricks in order to mitigate some of the challenges customers have, primarily on the new class of applications that we're seeing more and more. And that is where you need to mix analytics and transactions in one platform. So by leveraging OLTP, the initial use cases that drove this development in Databricks was for ML and AI models, where for feature store, having an OLTP system actually performs better for those customers. But it actually has extended by far more than feature stores, and I'll actually talk about that in the next slide. In order of what it is, underneath the hood, it's a managed Postgres service, but it has significant benefits because of being part of Databricks, which is first, UC governance. So if you're using already UC for your data platform, you can also use that for your OLTP. It also has disaggregated compute and storage, meaning being a Postgres service, you can actually scale it vertically, and compute can scale at different rates than your storage as well. And another great thing that it has unified data and query. What that means basically is that you're able to sync your Delta tables with OLTP. So you write to Delta and you tell it to basically sync to the database that you have. The workloads that we tend to see with OLTP are first the reverse ETL, which is the most common one, feature store, where you're writing it to OLTP again, but also serving data to applications. And this is something that we're doing in this use case, where we're populating an OLTP cache in a way with trading data that will then be used on our real-time trading dashboard. But also the most common OLTP use case as well is now something that you can use as well, which is where you're storing application state, and you use it to basically manage your application and what's happening within it. And lastly, the most standard OLTP system, which is why Databricks was created in the first place, which is you have your OLTP database and you want to do ETL within the analytics platform. The fact that you could sync between both of them makes it way easier to at least ingest into Delta. The last component of our use case is Databricks Apps. And Databricks Apps was created basically for the same reasons, where we're again seeing more and more data applications that are built on the analytics platforms. And what Databricks Apps does for you is basically makes it easy to host. It makes it easy to share within the company because you can have single sign-on, the same governance as you have with Unity Catalog. It has OAuth. So it has a lot of the features out of the box, so it makes it very simple to build these applications. It also is available for any web framework, which again makes it way easier to use and custom build your own dashboard applications. And it's very, very powerful in terms of what you can do with it. In principle, we use it primarily. We don't think you should be using it for building the next Facebook or anything. It's primarily focused on building that, extending those data applications on your organization and making it easy to release stuff instead of relying on other systems as well. And talking about that, this is where we have kind of this table to guide the decision making in terms of when do we use Databricks Apps? Do we use it for everything? Do we use it for some things? Well, the idea is that you would have, I tend to focus on simplicity. So if the dashboard is good enough, you don't need second latency. Minute latency is good enough for your teams and your use case. Go with dashboards. Don't overcomplicate building custom applications because then you're going to have to maintain that, and that takes a lot of effort and capacity from teams. But when your use case requires it, and Genie, for example, is not fit for purpose neither because you want to do more complicated stuff that is not enabled by what Genie can offer, well, we take you to app frameworks. And specifically on our one, we're using Plotly, but there's many open frameworks that you can use, which basically by using them will already give you a set of files and configuration files and app for you to get started. When that is not enough, and you require even more complexity, then that is where we go towards custom applications and where you could host your own web application as well. But this is all theory. We're going to hand it over to Matt.
The demo? The demo?
Yeah.
Okay.
Okay, you look at me like the demo's not going to work. So.
No, it's ready. It's good.
Yeah. So.
Okay, yeah. So like Matt was saying, so we went with Dash for our demos.
Yeah, let me.
This is your app, so you want to talk through it. So yeah, this is built with Plotly and Dash. One of the great things about this framework is you can specify custom refresh rates, particularly in this real-time use case. You can specify custom refresh rates for different components on the dashboard. So for example, we can have a graph that maybe updates, I think it's in this case every 5 seconds or something like that. And then perhaps the tickers could update more frequently. I think in this case, we've got an example here. So actually this table at the bottom, which is fairly meaningless in its own context, but this is updating every 500 milliseconds. And you can see that right-hand column there is actually showing the end-to-end latency measured from when the data was read off the API. So you can see currently we've got end-to-end latency of about 2 seconds from when the data is being rendered on the dashboard to when it was loaded off the quotes API. So we're doing better than our 60 seconds there. So yeah, I mean, do you want to talk through anything else on this dashboard?
Yeah, so a lot of this is, as Matt was saying, built through Dash. Basically, we're relying on that OLTP server to initially load the application, because obviously, if the user starts using the application, you need to preload the data from somewhere. That's where OLTP kicks in. And then as you want the data to be updated, we simplify it so that the logic of the sync itself can actually communicate as well with the application to basically update that more frequently so that you don't rely on that latency of the database itself. But yeah, this is basically gives you an idea of how you can actually rely on web frameworks. This was very simple to build. We used what was available within Databricks. Deploying it took a matter of seconds to do. Getting the dashboard to work, you could vibe code. It actually gets most of the dashboards built for you, but you can actually extend it for any library that you would like to use with Dash as well. And yeah, it's more. Not sure if there was anything else.
Yeah, and then just kind of working backwards, because we wanted to make sure we showed the dashboard, but kind of working backwards because we've got a few more minutes. So this is the DLT pipeline, which is populating this. So this is a nice thing here in that your DLT pipeline can combine kind of slow paths of data and fast paths of data, because obviously you only want to ingest the data once, but you probably want to write it to a Delta table, which is like your long-term storage where you're perhaps going to build a gold layer off it. But then also this sync at the bottom here. So this is what's writing to the cache, to the OLTP cache. So this bottom one here is doing a for each batch, writing to JDBC. And you still get the great latency, even though this top one is going to be much slower because it's writing to blob storage. So there's going to be like 5 or 6 seconds latency on this bit. This bit's still doing the sub-second latency at the bottom. And we're reading from one API over here. So just to kind of show that code, which I think Matt had in the deck as well. So this is where we're writing to JDBC there. Super simple. Obviously, this could be optimized in a lot of different ways, but this is kind of a really simple approach. And then we're reading from the quotes table here. And the quotes, this is defined using this here is the Python custom streaming sync, which is reading from the API.
Yeah, and you can see that you extend from an existing class. So data source is a common data source, common class which you extend to build your own ones. And it actually has not only data source, but it has like stream readers, stream writers, batch readers. So you can actually choose which one you need for your use case and build it up. Again, like we went only for stream reader, but if we wanted, for example, to make it easy to load from the trading API, like basically any data, any trading data for the past year, then obviously you wouldn't want to use stream for that. So you potentially could build a custom source, which still links together with everything, to read all that year data in one go.
Yeah, so one of the really nice things about this whole approach is that once you've defined it, you just do a spark.readstream.format, and then you give it the name of your custom streaming source or sink. So this is a really nice way you can give it to users. You can package it up so you can build a wheel file containing your custom data source. You can package it up, give it to users. They just run this spark.datasource.register with the class name, and then they can use this spark readstream.format. They can also use it in SQL, in a SQL statement. Use it DLT, structured streaming, wherever they want. Like Matt was saying, it supports batch as well. And then they can just use this in the same way. So it's a really nice way to package up these connectors.
So yeah, I think like if you have a team, like a data team, multiple sources, you can think about this team building like all these native well, not native connectors because they're not native, but all these connectors and made them available to all the teams within the organization so that they could basically pull data from systems that they couldn't do before. Obviously, there's Lakeflow Connect. Again, native connectors, Lakeflow Connect, whatever is out of the box, I would generally move towards that because then you don't have to build that massive class. But still, it's very powerful for anything that is not supported. And yeah,
Okay, I think that's
Okay.
everything. So yeah, big thanks again. Go on.
I was just going to say the moral of the story is don't be fooled by the way we dress. We do some cool stuff at Barclays. And we are hiring. So, and if you want to, you can still wear T-shirts to work.
Thank you.
Thank you.
Thank you.